We are solving question number 51 of GATE 2016 Chemical Engineering paper, and the question is related to process control and instrumentation subject. The question is, a liquid flows through an equal percentage valve at a rate of 2 meter cube per hour when the valve is 10% open. When the valve opens to 20%, the flow rate increases to 3 meter cube per hour. Assume that the pressure drop across the valve and the density of liquid remain constant. When the valve opens to 50%, the flow rate in meter cube per hour rounded off to second decimal place is dash. So in this given question, we have been given an equal percentage valve. So for equal percentage valve, we can write the flow capacity, that is the ratio of this flow at any valve position x to the maximum flow, that is f of x, is equal to alpha raised to x minus 1, where x is the valve opening and fx is the, you can say it as flow capacity characteristics, and the corresponding plot for this equation will be f of x and x will vary from 0 to 1. So the flow equation, you can write this as f is equal to cv f of x under root of delta p upon rho. Now in this given question, we have been given that delta p is constant, the density is also constant. So the flow, we can simply equate it to this f of x. And now we have been given different scenarios, that is at the flow rate of f is equal to 2 meter cube per hour, the valve is 10% open, that is x equal to 0.1. If the valve opens to 20%, that is x equal to 0.2, then the flow rate becomes 3. And if the valve opens to 50%, that is x equal to 0.5, we have to find the flow rate. Now we can simply write this equation as f is equal to alpha raised to x minus 1. There will be some constant that will eventually get cancelled out. So we can write this as, let's say for scenario 2 and 1, we can write it as f2 upon f1 is equal to alpha x2 minus x1 upon x2 minus 1 upon alpha times x1 minus 1. So this will become alpha raised to x2 minus x1. So f2 we have been given as 3 and f1 is 2. So it will become 3 upon 2 is equal to alpha raised to x2 is 0.2 and x1 is 0.1. It will become 0.2 minus of 0.1 equal to alpha raised to 0.1. So we will be having 1.5 is equal to alpha raised to 0.1. That will give us ln of 1.5 is equal to 0.1 times of ln of alpha. So from here we will find the value of alpha, ln of alpha is ln of 1.5 upon 0.1. So that will be 4.05. Now for second other case, we can write that f3 upon f2 is equal to, similarly we can write x3 minus of x2. f3 we have been asked to find, and f2, let's consider this third and second case, so f2 will be 3 times the valve opening is 50%. For x2 it was 0.2. That is, you can write this f3 is equal to 3 times alpha raised to 0.3. Now alpha from here we can find it as 57.397. So we will put that value over here and we'll be getting the value of F3S D into 3.3702. It will come around 10.11. So the final answer we can write is that when the valve opens at 50%, the flow rate in second decimal place is around 10.11.